Hello dear friends. So this is our concrete civil concepts classes, and in this video we will going to discuss some important MCQs on concrete technology and RCC. This is our part A, and earlier I have uploaded important questions on steel structure, and the link is given in your description. So go and refer that. Okay, this is our concrete technology on RCC part A section. Okay, so before going to waste our time, let's discuss our important questions. The first important question is the need of water content in high strength concrete mix is. Okay, so we know the need of water content in high strength concrete is very low. As the water content in concrete mix increases, the strength decreases. Okay, but the workability of mix increases. Okay, so for high strength concrete admixtures we are using such as plasticizers and super plasticizers. Okay, along with the very less water cement ratio. So option A is correct. The need of water content in high strength concrete, that is very low. Move on to the next question. Cause of loss of pre-stress in a pre-tension pre-stress concrete beam is the friction. So we know the loss due to friction occurs only in the post-tension beams, while the other losses, that is elastic deformation of concrete, shrinkage of concrete, and the creep of concrete, occurs in both pre-tension as well as in the post-tension beams. So here option A is correct. Move on to the next question. The concrete mix used in the tank body of water tanks should be at least of grade. The answer is M20. Okay, so as we know all that the construction of water tank, the minimum grade of concrete is M20 for plain concrete and M30 for reinforced cement concrete. And likewise, we have a grade M40 for pre-stressed cement concrete. So this is confirms the IS code of 3370. You can refer that, and this is important questions which is usually asked in every examinations. Okay, so for water tank the minimum grade of concrete is M20. Okay, move on to the next question. In limit state method of design, maximum compressive strain in axial compression in concrete is taken as 0.002. Okay, so this is again the important question is here you know the maximum compressive strain in axial compression in concrete is taken as 0.002. Option B is correct. While we know the maximum compressive strain in maximum compression in concrete in flexural compression. Okay, so we know the flexural compression, the maximum compressive strain is taken as 0.0035. So according to IS 456/2000. So if the question asks the maximum flexural compression, okay, flexural compression, then the option A is correct, 0.0035. If you are having a question like maximum compressive strain that in axial compression, that then the answer will be a 0.002. Okay, so please make a note. For axial compression this is 0.002, and for flexural compression it is 0.0035. Okay, so move on to the next question. A continuous beam is deemed as deep when ratio of span, that is L, and D as. Okay, we know the option A is correct, less than 2.5. A deep beam is the beam when the ratio of span to depth ratio is less than 2.5 for continuous beam. Okay, we are having two conditions here. For continuous beam, a deep beam is less than 2.5. Okay, and if you are having a simply supported beam, then the ratio of span and depth is less than 2. Okay, so here in the question continuous beam is asking, so the option A is correct, less than 2.5. For simply supported beam it is 2. Okay, so move on to the next question. A mid span of beam where bending moment is maximum and shear is least, the direction of cracks will be, okay, the direction of cracks will be here the vertical. Okay, we know at the mid span of the beam shear is generally negligible, or you can say zero it is, and due to some principal fluctual stresses the cracks are vertical here. So you know the cracks will be vertical here. So here option C is correct. And move on to the next question. The purpose of adding steel reinforcement in the design of RC columns under axial load is to account for accidental and eccentricity of loads. Okay, so we know the to account for accidental loads and eccentricity of loads as per Indian Standard 456/2000. It specifies the minimum reinforcement in the column as 0.8%, and we know the minimum bar dia as of column as 12 mm. Okay, so to account for accidental and eccentricity of load, the purpose of adding steel reinforcement is under axial load is to be considered. So option B is correct. Okay, so move on to the next question. The minimum longitudinal reinforcement in RCC column. Okay, we know the minimum longitudinal reinforcement in RCC column is 0.8% of cross-sectional area of the column. Okay, as per again Indian standard 456, we know the minimum cross-sectional area is 0.8%. Okay, this is directly asked in your examinations. Okay, this is important in the topic columns. Okay, so move on to the next question. The critical section for shear in flat slab. Okay, we know the critical section for flat slab is at a distance of d upon 2 from the periphery of the column. Okay, so where we know what is d? D is the effective depth of the section. So option C is correct. You have to remember the critical section for shear in flat slab is d upon 2 distance from the periphery of the column. Okay, so move on to the next question again. The minimum percentage of HYSD bars in RC slab compared with gross concrete area. Okay, so we know the minimum percentage of HYSD bars is 0.12. Okay, so HYSD bars are nothing but this is high yield strand deformed bars, and again from Indian standard IS 456-2000, we know when HYSD bars are using, then the minimum reinforcement in slab is 0.12%. So option C is correct. And we know if we are having a mild steel bars, okay, or you can say Fe250 bars, then the minimum reinforcement in slab is 0.15%. Okay, so in that case option B is correct, that is 0.15%. But here we are having a HYSD bars, so option C is correct. Okay, so you have to keep in mind. So move on to the next question. Deflection can be controlled by using the appropriate, we know, the span to depth ratio. Okay, so for to control the deflection, we have to control the span to depth ratio. So again, as per Indian standard, that is IS 456-2000, we know the vertical deflection limits for satisfy the span to depth ratio for different conditions, like it should not be greater than 7 for cantilever beam. Okay, span to depth ratio should not be greater than 7 for cantilever beam, and again for 20 for simply supported beam, and 26 for continuous beam. Okay, so the span to depth ratio is important to control the deflection. Okay, so this is your clause, important clause in IS 456-2000. So move on to the next question. So the heat of hydration of cement can be reduced by, that is by reducing the proportion of C3A, that is tricalcium aluminate and tricalcium silicate. Okay, and and by increasing the dicalcium silicate. Okay, so the heat of hydration of cement can be reduced by reducing C3A and C3S, and also increasing the content of C2S. We control or we reduce the heat of hydration. And we know the massive structures like dams, which are built using the low heat cement. Okay, so which has more dicalcium silicate, that is C2S, and reduced C3S proportion. So for massive structures, we know the C2S content is high, and our C3S proportion is reduced. So to control the heat of hydration of cement, we have to reduce the proportion of C3A and C3S. Okay, so option A is correct. Move on to the next question. If the angularity number of an aggregate is increased, then the workability of concrete using this aggregate will be decreased. Okay, so we know the angularity number is the percentage of voids in excess to 33%, and if we are having higher the angularity number, more the angular aggregates will be, and the less workable is the concrete mix. Okay, so this is a thumb rule. We are having, if we are having a higher angularity number, then we are having a more angularity number aggregates, and less workable. So for rounded aggregates, we are preferring in concrete because of the better workability and higher strength. We know the rounded aggregates are preferred in your for better workability and better strength. So option B is correct. The workability of concrete for this type of aggregate will be decreased. So move on to the next question. The value of Vee-bee time for workability. Okay, so you know the VB time refers to the degree of workability here, and if we are having a low workability, so for low workability, we know the option B is correct, 5 to 10 seconds. If we are having a high workability, it means the VB time will be less than 2 seconds. Okay, and if we are having a degree of workability as medium, then we are having a VB time as 2 to 5 seconds. So option A will be correct in that case if we are having a medium workability, and if we are having a very low workability, then our VB time will be 10 to 20 seconds. Then in that case option C will be correct. But here we are having a low workability. So for low workability we are having a 5 to 10 seconds. Option is correct. So move on to the next question. If the compacting factor of concrete is 0.9, then the workability will be, okay, here this is again your workability question, and this is the question is asking like for compacting factor of 0.90, the workability will be, we know for compacting factor greater than 0.92 or above, we are having a degree of workability as high, and if we are having a degree of workability medium, then we are having a compacting factor of 0.85 to 0.92. And if we are having a degree of workability very low, then we are having a compacting factor 0.75 to 0.8. So for medium degree of workability, the option C is correct. That is the compacting factor will be 0.85 and 0.92 in that case. Okay. So here option C is correct for 0.90 type of compacting factor. Move on to the next question. The side face reinforcement, if required in a T-beam, will be. We know the side face reinforcement is required and in the D beams. Okay, we know the side face reinforcement is required in the D beams. Okay, and it is provided as 0.1% of the total web area, and so option B is correct, and it is equally distributed on both the faces. Okay, so you have to keep in mind that is the side face reinforcement of 0.1% of the web area is provided equally distributed in all the faces, in both the faces. Okay, so option B is correct here. Move on to the next question. Drops are provided in flat slab to resist. Okay, so this is important question, and drops are provided to resist shear. We know drops increases the shear strength of the flat slab floor, and also drop panels increases the slab's negative moment capacity. So drops are provided here to resist your shear only. Okay, and here the drop panels also reduces the deflection by stiffening the flat slabs. So option B is correct. Okay, move on to the next question. Pitch of a transverse reinforcement should not be more than, the pitch of transverse reinforcement should not be more than, we know the pitch of transverse reinforcement will be your least lateral dimension and 16 times the diameter of longitudinal bars and 300 mm, whichever is minimum value we are considering as a pitch. Okay, so this is your LLD, that is your least lateral dimension. Okay, so and again the 16 times the longitudinal diameter of reinforcing bar and 300 mm, whichever is the lesser value we will adopt it. So option D is correct in this case. Okay, move on to the next question. As compared to WSM, limit state method takes concrete to a higher stress level. As we know, the material factor of safety in limited state method of design is less as compared to that of the working stress method. So for limited state method, it leads to the concrete to a higher stress level. Okay, so option A is correct. Okay, so next move on to the next question. That is the last question, that what should be the minimum grade of reinforced concrete in and around sea coast construction. Okay, minimum grade of reinforced concrete it is asking. So this is depend upon the exposure conditions, and this is for mild exposure. If we are having a minimum grade of plain cement concrete, then the mild exposure what will be, it is given in your Indian standard book. And for minimum grade of reinforced concrete for mild exposure, it should be M20. Okay, and if we are having a moderate exposure, then our minimum grade of reinforced concrete will be M25. So keep in mind here. And for severe exposure condition here, okay. So for severe exposure condition, we are having a minimum grade of concrete as M30. Okay. So here you can refer, your answer will be your M30 as minimum grade for if you are having a construction around sea coast. Okay, so we know that the use of slag or pozzolana cement is advantageous under such conditions, under this severe condition. So option C B is correct here, M30. Okay, so this is all about our today's session, and we will discuss some important questions further on different topics and also on your RCC Part B, Part C. Okay, so do like and subscribe for more videos of civil engineering subjects. Okay, and share with your friends. So thank you so much for watching.